Assalamualaikum and a good day to all the speakers. My name is Zaidatul Adnan from Faculty of Civil Engineering Technology, University Malaysia Pahang. My co-author are Dr. Farhayu Ariffin, Dr. Sharifah Maszura Syed Mohsin and Dr. Hasanah Abdul Shukor. The title for my presentation today is The Assessment on the Acceptance of Waste Materials as a Partial Cement Replacement in Malaysia Construction Industry. This is my presentation outline. For the introduction, the Malaysian construction industry has approached a critical limit, which is in several years, large construction building and infrastructure development projects had led to increasing in cement production. The production of cement will cause wider environmental implications such as air pollution, water pollution, and soil pollution, which are very dangerous for human health. This is due to the manufacturing of cement are one of the factors emission of dust, toxic, and carbon dioxide, which is a significant contributor of greenhouse gases. On August 9, 2014, Lafarge cement production capacity was about 12.95 million tons, YTL cement at 5.95 million tons, Cima at 3.4 million tons, Tasik Corp at 2.3 million tons, and both Hume Cement and Holcim Malaysia at 2 million tons each year. Figure 1 shows the cement production. Generally, in cement production, carbon dioxide is emitted in a rotary kiln during the production of clinker, which a cement component calcium carbonate was heated at high temperature in order to induce a series of complex chemical reactions. Carbon dioxide is produced as a byproduct during calcination process that occurs at temperature of 600 degree to 900 degree at the upper cooler end of the kiln or precalciner. This will have resulted in the conversion of carbonates into oxides. The carbon dioxide will release to the atmosphere as the process goes on. With the huge production of cement stated, the emission of carbon dioxide also will increase. However, the problem that related from cement production can be overcome by replacing cement with waste material in cement production. In 2001, 5.5 million tons of waste material had been generated and only 5% waste material were recycled and the remaining 95% is disposed of in overpopulated landfills in Malaysia. Thus, many studies on waste material as a cement replacement in concrete construction has been carried out in the last few decades, and there is a great potential of using them in construction industry. Therefore, this study is conducted to investigate the assessment on the acceptance of waste material which are fly ash, coal bottom ash, rice husk ash, palm oil fuel ash, and eggshells as a partial cement replacement in Malaysia construction industry. For the problem segment, the production of cement not only contributes to the emission of carbon dioxide, dust, and toxic, but it also consumes large amounts of natural resources that lead to global warming issue. Along with all the problems that cause from cement production, the use of waste material is the best way to overcome the problem. By using waste material as a partial cement replacement shows the best results in concrete production. Unfortunately, the use of waste material as a partial cement replacement is still not widely used in construction industry nowadays. Thus, a study should be done to investigate the acceptance of waste material as a partial cement replacement as well as the factors of unimplementation of waste material in construction industry. The objective of this study are to investigate the acceptance of waste material as a partial cement replacement in Malaysia construction industry. For the literature review, there are 5 types of waste material which are fly ash, coal bottom ash, rice husk ash, palm oil fuel ash, and eggshells. As you can see from the table 1 until table 5, it shows that the chemical composition of these 5 types of waste materials, the main compost of these 5 types of waste material are silica, ferrous oxide, and alumina, with minor quantities of calcium oxide, sodium oxide, magnesium oxide, and sulfur oxide. It has been endorsed by Zaidatul, Pitakul, and Cherarot that these 5 types of waste material host a well-pozzolanic properties which could enhance the strength and durability performance of concrete. This is supported by Rosaini 2008. The presence of high amount of silica makes it a valuable material for use in industrial application. For research methodology, basically in this research, there are three types of method for data collection. First is extensive literature review. All the general information such as types of waste material available, properties of waste material, and the advantages are gathered in order to achieve the objective of the study. The second method of the data collection is face-to-face interview session with 10 respondents from private and government sector, especially with the registered contractor, consultant, and supplier who has related in construction industry. The last method in this study is questionnaire design. For this study, 140 sets of questionnaire was distributed to all respondents from both private and government sector who has related in construction industry all around Peninsular Malaysia. For the results and discussion, Figure 3 shows the percentage of each type of company surveyed. The result shows that 88.4% and 11.6% respondents are from private sector and government sector respectively. From all the respondents, only 2.5% respondents are familiar in using waste material as a partial cement replacement, and remaining 79.5% respondents are unfamiliar in using waste material in concrete production. Apart from that, only 16.1% company that received inquiries in using waste material as a material for partial cement replacement, and 83.9% respondents never experienced in using waste material as a material in cement replacement. With further interview session with the expert parties, the factors of unimplementation of waste material as a material for partial cement replacement are summarized in the figure 6. From the graph, the first factors of unimplemented of waste material in concrete production are because of lack of quantitative data on properties of concrete using waste materials, and company itself not sure with the acceptance of client or end users regarding the concrete using waste materials. The percentage for both of the factors are 63.4%. The second factors of unimplemented of waste material is company, client, and end user itself unfamiliar on type of waste material that can be used as a partial cement replacement. The percentage of these factors is 62.5%. Next is fear of product failure or service life of construction that using waste material as a material in cement replacement is the third factors with percentage of 60.8% followed by 60.7% percentage with the fourth factor, which is fear with quality of product that using waste material are not same as quality of product of ordinary Portland cement. The fifth and sixth factors of unimplemented of waste material as a partial cement replacement are lack of general knowledge regarding the usage and benefits of waste material, and company does not have special permits or regulation in order to use waste material as a partial cement replacement. The percentage for both factors are 60.7% and 59.8%. Besides that, because of lack of equipment for processing waste materials, lack of market to buy waste material, and extra space is needed to store and keep waste material in order to use in partial cement replacement are make it in the 7, 8, and 9 factor of unimplemented of waste material in concrete production. The percentage for each of the factors are 58.9%, 58%, and 57.1% respectively. Finally, the last factors of unimplemented waste material in cement for concrete production with the percentage of 48.2% is due to financial and time constraint in processing of waste material for cement replacement. Despite of all the factors of contribute to unimplementation of waste material as a partial cement replacement, there are several solutions and recommendations that can be derived from the interview session and questionnaire design in order to overcome the problem related to unimplemented waste materials in cement for concrete production. Figure 7 shows the summarized of solution and recommendation that can be made according to industrial perspective. From the interview session, with the expertise and questionnaire design that had been distributed, 71.5% respondents agreed that more educational program or conference should be done in the future in order to introduce the availability and applicability of waste materials as a partial cement replacement, so that can help to encourage industry and spread awareness regarding the benefits of usage waste materials to the relevant end parties and society itself. Besides that, about 70.5% respondents are agreed more research, analysis, and data regarding waste materials, properties, and benefits should be done before using in construction and can be as a reference for future development. Apart from that, 70.5% respondents also agree that in order to implement waste material as a material for partial cement replacement, industry itself should be more open and innovative in accepting this new technology. Other than that, 69.6% respondents agreed that university and industry should create a better connection in order to share knowledge regarding the usage of waste material and their application in concrete production. Lastly, 62.5% respondents agreed if government can take action regarding this matter, which is the government should approve or include the usage of waste material as a partial cement replacement for concrete production in clause, so that can be used as a reference or guidelines. As a conclusion, based on previous research, waste materials such as fly ash, coal bottom ash, rice husk ash, palm oil fuel ash, and eggshell are suitable and can be used as a material cement replacement, since this material possesses a good pozzolanic material as cement itself. A good pozzolanic properties can be measured by referring the chemical composition of one of the materials. Therefore, it is very important to gather all the data regarding properties of each of the waste material from previous researchers, so that can be a reference and guideline in future, since industry itself has a little knowledge about waste material as a partial cement replacement. Besides that, by implementing waste material can help to save energy, reduce wastage, save natural resources, reduce air, soil, and water pollution, as well as can reduce greenhouse gases. Thank you.